Welcome to my video. Today I am going to solve a Python for data analysis Numpy exercise and recording it for future purpose. Please watch along if you find it interesting. So the first one is to import Numpy. Let's start. Import Numpy as NP. Next is to create an array of 10 zeros. That would be np dot zeros, and we'll put in the number of elements we need, which is the same. If we put in a tuple in place of 10, if we put in 5 by 2, it will return a 2D array just like this. But here we need just 10 arrays in one dimension. Next is to create an array of 10 ones. That would be np dot ones. And just like zeros, we can put in a tuple if we need 2D array. But since this is just one dimensional, we will put a single number. Create an array of 10 5. So there are a couple of ways to do this. We could either create an array of 10 zeros and add a scalar of using a scalar operation. We can add 5 to each of those elements, each of those 10 elements, or we could create an array of 10 ones and multiply each by 5. Let's use the second method here. Oh, sorry, I need to create an array of ones. Next one is to create an array of integers from 10 to 50. For this, we will use arange function or method. And p.arange, we need integers from 10 to 50. So we will stop at 51 as the last one is exclusive. 51 won't be included, and we need this in steps of 1. We don't really need to pass in the third argument here as the default is 1, but even putting it won't change it anyway. Next is to create an array of all these even integers from 10 to 50. So for this one, we just have to use the same function, but the step size would be 2 starting from 10. 10 to 51 with a step size of 2. So this gives an array which goes from 10, 12, 14, 16, 18 and so on up until 50. Now we have to create a 3 by 3 matrix, or a 2-dimensional matrix with values ranging from 0 to 8. So in total from 0 to 8 there are 9 elements. We could create a range going from 0 to 9 and then reshape that array into a 3 by 3 matrix. Starting with 0, end at 10 with steps of 1, and then reshape this. I will show you what this will give. The output of this one would be an array going from 0 to 9. Now we can just reshape this 3 by 3 matrix. Make that a tuple. Wait. Also, I made a mistake here. It should be going till 9, as if it was going till 10, then in total we had 10 elements, and 3 by 3 matrix will only have 9 elements, so it cannot reshape if we have more than or less than the required number of elements. It works here. Next up, we have to create a 3 by 3 identity matrix. The way to do that is to use the I method or I function, .I, and since an identity matrix is a square matrix, we can just put a single element and it will return a matrix which will have all of its diagonal elements as 1 and all the remaining elements should be 0. Next is to use Numpy to generate a random number between 0 and 1. Well, we have some functions to generate random number in Numpy. I will show you those one by one. First up is np.random.rand. If we check the doc string, it shows that it will return random values in any given shape. So we need just one random number. We will input 1 here and it will return one random number between 0 and 1. So what this rand does is it returns a random sample from a uniform distribution, that is 0 and 1. We have another function which is rand_n that returns random numbers from a normal standard distribution which is centered around 0. That will be the next question. We will show that, but for now let's check this one. This number, as you see, would be different from the output which is already given in the paper. That is because it's a random number and every time it will generate a new random number. If I press enter again, it will change this number into a new number. See, right now it's 0.25. By pressing again, it's generated a new random number which is 0.1649. Next is use Numpy to generate an array of 25 random numbers sampled from a standard normal distribution. So now we have to use the standard normal distribution and have to generate 25 random numbers. And v.random.rand, and we have some different options as well. Rand int, which generates random integers, and then there are other options as well. For normal distribution, we would go with rand n. The n at the end signifies the normal distribution. And we put 25 as our argument, which produce 25 random numbers. Now please note only one bracket here. Even though this looks like a 2D matrix, but it is essentially just one dimensional vector, and that is signified by the one bracket, one opening bracket and one closing bracket here. For the 2D matrix, you would have two opening brackets and two closing brackets as is given in this question. Next up, we have to create this following matrix. So this one looks like it's a 2D matrix. It's starting from 0.01 and is going all the way up to 1. So there are a couple of ways again we can do this. One is to use the arange function. We could start with 0.01, go up till 1.01, as the last one won't be included, that is exclusive. And we could use the step of 0.01 The other way is to start with 1, go up to 101 with the step size of 1 and then divide it by 100. So I will show you both ways. One is just use the proper floating point numbers. The second is to create with integers and then do a scalar operation to achieve the desired result. So this one produce a one-dimensional matrix which is our required matrix in 2D. To reshape it, in total there are 100 elements going from 0.01 to 1.00. We will reshape it into 10 by 10 matrix. So we get our desired result. We will also try the second method I explained earlier. So in this one what we did was we created a range of 1 to 100 with a step size of 1, divided each element by 100, which gave us our desired elements, and then we reshaped that 1D array to a 2D array of 10 by 10. Next, we have to create an array of 20 linearly spaced points between 0 and 1. The way to do that is to use a function called linspace. Now see, with a range, we create a range of numbers with a given step size. So if it's 1, each element would be 1 higher than the previous element. With linearly spaced, for linearly spaced points, the third argument in that would be the number of points you want, equally spaced points, and the system will automatically, Python will automatically calculate the step size required for those many number of points. If you check the doc string, we have a start, we have a stop, and the required number of points. And the stop is inclusive, unlike the a range function where the stop is exclusive. The stop for linspace is inclusive. Now we have an option of setting it exclusive by using the endpoint, which is by default given as true. We could put another argument if you don't want it to end at 1, rather you want it one step earlier than 1, then you could use the argument endpoint is equal to false, and that will be taken care of. Now we are given a matrix here which goes from 1 to 25. So in total there are 25 elements and it has been reshaped in 5 by 5 matrix. What we have to do here is to write the code that reproduces the output of the cell below. Basically we have to index the given matrix to produce uh, this output. Let's run this one first. Next we have to use the Numpy indexing and selection. We are given a few matrices and we are asked to replicate the resulting matrix outputs. So first we are given a matrix which is a 5 by 5 matrix which has been created using our arange function, which goes from 1 to 26, 26 being exclusive. So it goes from 1 to 25. In total, there are 25 elements, and it has been reshaped into a 5 by 5 matrix. So let's run this first. Now here we have to select this output using indexing, which goes from 12, 17, 22 in the rows, and then all of these columns. So basically in this matrix we have 5 rows, which goes from indexing 0, 1, 2, 3, 4. We have to select the last 3. So 0, 1, 2, starting from 2 we need 3 and 4, and for columns starting from 1 we need 1, 2, 3, 4. So starting from 2 we go to everything below 2, which is signified by a column. If we put in a row, that row would be exclusive. So if we select 2 colon 5, this will imply that we want to select the rows at index 2, 3 and 4, not 5, as 5 is exclusive. But since we are going till the end, we don't need to put in that last row number or row index, and we can just put 2 and then column, starting from 2 everything. And then similarly for the columns, we can start at index 1 and then everything till the end. Next up, we have to use indexing to select the element 20. Now this 20 is here, which is in 4th row and 5th column. So since this is a single element, we don't need to use columns here. We could directly just select index 3 comma index 4. Next we have to select this 2D matrix of 2, 7, 12. So if we check our original matrix, we are selecting this 2, 7, 12, which is row 1, 2, 3, but column 2. So let's do that here. This is the entire matrix. This returns us the rows 1, 2 and 3. Now we need column 1. Now see, I only need one column. If I put just one, see what happens. It returns a 1D array of 2, 7 and 12. If I need this two-dimensional array, I need to use the two-dimensional notion here as well. And since I only need one column at index 1, I will end it at 2, which is exclusive. So it will return a two-dimensional array. For this one, it's just a one-dimensional array and it is the entire last row, which was 5th row at index 4. So this is simpler. We don't need to put anything for the column. We just need to select the row. Which is the row at index 4. Now for this one, we need to select 2 rows, both of the last row. And remember, this is a two-dimensional array, but we don't need to select anything for the column. So here, if we use uh, index 4 after colon, as 4 is exclusive, it will return only one row, and that would be one dimensional again, I believe. No, actually it is two dimensional, but it's returning only one row. If we use 5, which is exclusive but not available within this matrix, it will still return both third and fourth index rows. Now next up, I need to get the sum of all values in the matrix. So this is simple. We could use the sum method with the matrix. Mat dot sum, and this returns the sum of all the elements within that matrix. Similarly, for standard deviation, we could use the function std, mat dot std, and this returns the standard deviation of all the elements within the matrix. Now we have arrived at the last one. Get the sum of all columns in the matrix. So this is a little more complex than the first one, mat.sum. If we check the doc string, we have an option for an axis here, which by default is none. Now we could put in two options here, axis as 0 or axis as 1. Let's check for both. Remember, 0 is row, 1 is column. So for 0 would be adding up all the rows together. Yes. So what 0 is doing is, the axis which is selected is rows, so it is adding up all the elements of the same column at the different rows. Let's check the matrix as well. You see, what is happening when we put 0 is, it is taking the axis as rows and then adding up the sum from top to bottom. So 1 plus 6 plus 11 plus 16 plus 21, that is 55. 5 plus 10 plus 15 plus 20 and 25 is 75. When you use axis 1, the axis turns into column, and the sum function will add the sum of all the columns for the same row together. So first one would be 1 plus 2 plus 3 plus 4 plus 5, which is 15, and the sum of all of these last elements is 115. So that's all for this video. Next up would be pandas. Thanks for watching.